Okay, so as always, turn on your cameras and then we'll start lah. Okay, so today we're going to be looking at 1.2, okay, which is the title of resolution of forces. Okay, so before this, we looked at the words resultant force. Okay, resultant force is kalau kita gabungkan all the forces and then it becomes one force. Okay, we represent all the forces that are involved as only one. So that's called a resultant force. Okay, but resolution of forces, okay, dalam bahasa Melayu, resolution is called leraian. So if you are given a force, okay, kalau kamu diberi one daya, okay, satu force, what you need to know is how to break up the forces into different parts. So the first subtopic is combining all the different parts into one force. Okay, but now the resolution of forces, leraian daya, is if I give you a force, I want you to break it apart, okay, into components that we all can understand mathematically. Okay, so this subtopic and the next subtopic is very heavy on the mathematics lah. Okay, so pay as close attention as you can, and if you don't understand anything, you want me to repeat something, please unmute yourself and let me know. Okay. So, in this situation, this example is in your textbook. So you have this boy that is playing this tarik upe lah. I don't know how many of you done this when you were young, but last time when we were younger, I used to do this a lot lah. It's a lot of fun lah. Okay, unless kamu punya upe ni kan, suddenly get stuck in a hole and then you cannot get out lah. Then it's not so fun anymore lah. Okay, but actually it's very fun. Okay, you can play a lot of racing games with this. Yeah. So the thing is this lah. So the acceleration is going this way. This is the direction of the acceleration. And as I said before, we always think that okay, resultant force, dia punya direction of the resultant force must always be the same as the direction of the acceleration. But the problem is our pulling force is this way. Okay, do you see the pulling force over here? Our pulling force is that way. So the question is, how come this boy is not following the pulling force? How come this boy is going forward? Okay. So in normal life, like in our lives, bila kita buat macam ni kan, kita tidak fikir bah. Kita tahu kita tarik jap, and then the boy will move. Okay, but physics is all about this lah. We're trying to make sense of how come if the tarikan is this way, why is the boy not moving the same way? Why is the boy moving forward? Okay, and that is answered by this one, the resolution of forces. Okay, and this is what we're going to explore today. Okay, so this is due to the pulling force having a vertical and a horizontal component. So this is a very important thing. Okay, resolution of forces is the process of resolving a force into two components. So the basic idea is every single force that is sengit lah, okay, that is sengit, okay, we can actually resolve that force into two components, okay, which is the vertical component and the horizontal component. Okay, if you remember our previous lesson kan, kalau kamu ada satu tarikan ke sini, satu daya ke sini, dia punya resultant force is this way. And how do we do that? We do that by two methods. Either we draw a parallelogram and then we draw the diagonal, or we make a triangle. Okay, the resultant force triangle, remember? So here and then here, so the resultant force is this way. So resolution of forces is basically the terbalik of resultant force. Except that in this case, we want to talk about daya yang sengit lah, sengit macam ni lah. Okay, so we want, kalau kita mau kasih leraikan, we want to split it into a horizontal and vertical component. And that's all we're interested in today. Okay, we are interested to learn, what we want to know is how do I break apart, okay, a single force that is of a certain direction yang ada angle, okay, there's always an angle to the force lah, okay, into two components, dua components saja, okay, ini yang paling minimal, okay, maybe in real life there are more than two components, but I only want to know two lah, okay, which is horizontal, okay, yang kiri kanan, and the vertical component, which is atas bawah. Okay, that's the skill that we need to learn today. How to pecahkan, okay, one single dia to become two. Okay, so it says over here, the pulling force acting on the boy can be resolved into two perpendicular components. They must be 90 degrees. Okay, the vertical component is to balance the weight of the boy. Sorry. Okay. And the horizontal component overcomes the friction and moves the boy to the right. So sebenarnya, apa yang menggerakkan this boy ke depan is the horizontal component. Okay, itu yang menggerakkan the boy forward. But of course, it has to overcome the frictional force lah. Dia mesti mengatasi daya geseran. Okay, to make sure that the boy is moving forward with an acceleration. If the boy is moving at constant speed, then the horizontal component and the frictional force is the same. Okay, we established this last week. Okay, so let's leave that aside for now. So this concept, this resolution of forces can be explained in these two situations. Why does a book stay on the inclined plane and not slide down? Kau tengok, kalau tak satu buku begini kan, tapi dia tidak dapat bergerak ke mana-mana. Okay, so the resolution of forces solves this problem or helps us to understand macam mana ini boleh berlaku. Okay, why is the lady dragging her luggage instead of pushing it? Okay, kalau kamu pernah bawa bagasi bahkan, tiadalah orang yang akan tolak the bagasi ke depan sambil berjalan, especially at this angle lah. Okay, usually if you're gonna have an angle kan, kau mesti tarik, and that's very logical. I don't think I've ever seen anybody yang sudahlah ada sudut kan, lepas tu dia tolak lagi itu back ke depan. It's very illogical lah. Okay, so usually we will tarik back. Okay, so let's think about this. So a boy pulls a trolley with a force of 70 newtons. Okay, I don't think this example is in your textbook, so pay attention to this. In the direction of 20 degrees from the horizontal floor. Okay, so as I said before, since the force is this way, the resolution must start at the same point. Okay, one horizontal and one vertical. So the important point to note is this, tempat bermulanya daya kamu, okay, where your force starts, the point where it begins is where you start to resolve it. Okay, and you only resolve into two components, which is vertical and horizontal. Disebabkan this force is going up and left. Okay, I mean this is up left okay, this direction. So the vertical component is up and the horizontal component is going to the left. Okay. In the same way, in the case of this guy that is mowing the lawn atau menolak trolley, okay, bila kamu menolak trolley, your force is downwards. Okay, kamu downwards and to the right. Look at this arrow. Okay, so when you split it into two forces, it will be downwards and rightwards. Okay, so it's not that difficult. You just have to pecahkan the sengit force into two components. So there are four sengit forces. Okay, there are four sengit forces. One is this one. One is this one, which is up left. Okay, so the horizontal component is ke atas dan ke kiri. The second sengit force is this way. What are the two forces? Ke arah mana?
Up, right.
Okay, up and right. Okay. Thirdly is the one that's the same as this, okay, which is like this. So the component is to the right and to the down. Okay. So the direction of the sengit force akan memberi macam petua kepada kita lah, tells us, okay, where is the direction of the two perpendicular forces. Okay, dua daya yang berserenjang must tell us lah. Okay, so the direction of the force will tell us. And that's a very good clue for us lah. Okay, so there are two methods to do this lah. One is if we use a triangle method. Okay, so the triangle method, last week we learned that when we use the triangle method, we can get a resultant force like this. Okay, so if you have to the right and to the up, then the resultant force is this one lah. Okay, so kerja kita hari ini adalah daripada merah kita mau bentukkan yang hijau. Okay, from the red color we want to find out what is the green color yang menghasilkan yang merah. Okay, sebelum ini saya bagi yang hijau, saya suruh kamu tentukan yang merah. Today is I give you the red color, you tentukan the two hijau. Okay, that bila digabungkan akan menghasilkan yang merah. So one of the method is to use triangle method. Of course, the other method that I taught you was to use the parallelogram method lah kan. Okay, then this is the resultant force. Okay, so there, but the parallelogram method not so useful over here. Okay, today we focus on the triangle method. Okay, and sorry. Okay, so let's do a little bit of trigonometry. Okay, we have to do a little bit of trigonometry review just to remind you of what are the important things here. So when you split one force into two components, okay, and if there is an angle over here, so let's call this A, B, C lah. Okay, side A, side B, and side C. And let's say there's an angle of theta over here. Okay, sorry. Okay. Okay, so we know from our old friend Aso, Aka, and Atwa, okay, that cos of this one is the adjacent over the hypotenuse, A over C. Okay, that's very logical lah. Okay, all right. Angeline, can you tell me in terms of A, B, and C, what is sine theta? And Brandon, tell me what is tangent theta?
Sine theta is OH, O over H.
In terms of A, B, and C in this triangle?
C over A.
C over A, yeah.
Wait. B over A.
Angeline, which one is the hypotenuse?
Oh, C.
Yeah, okay. Hello, please recognize the hypotenuse. Okay, Brandon, tangent, please.
B over A.
Okay, B over A. So this is a very important thing. Take note of this, people. Okay, because after this we're going to be using sine cos tangent. Okay, so be ready lah, be ready. But make sure that you know what is this as the so-called thing lah. How to determine the sine, how to determine tangent, how to determine cos. Okay, so kalau macam itu, I can say that since you said that cos theta equals to A over C, I can say that A equals to C cos theta. Okay, C cos theta. Okay, I move the C up lah. Okay, begitu juga I can also, sorry, never mind. So let's think about this. Now we change the A, B, and C to this resolution of forces thing. Now if we follow the triangle, okay, Fx, I'm going to call this yang tadi A bahkan, I'm going to call this horizontal component Fx, and I'm going to call the vertical component Fy. Okay, now according to our triangle law, Fx dan Fy bila bergabung, dia akan menghasilkan F. The resultant force will be F. So if I draw the triangle, it will look like this. Okay, the Fx, and then the Fy, I move it to this side, make it like a parallelogram lah. Okay, and then I put the angle of theta down here. Okay, so let's come back to this. So katua. Okay, Damir, can you tell me sin theta dalam segitiga ini, sin theta is apa per apa?
Fy per F.
Okay, very good. Fy over F. Fy kah? Oh yeah, okay. Okay, never mind. Sorry. Yeah, betul. Okay, and Daniel, what about cos theta?
Fx over F.
Okay, very good. Fx over F. Okay, so kalau begitu, sorry I'm going to change this to Fy and I'm going to change this to Fx. Okay, Elijah, from this equation over here, can you tell me what is Fy?
Sin x f.
Okay, so you bring the F up, okay, and you will get F sine theta. So this one is a very important relationship. Okay, the first relationship I want you to understand. The vertical component, okay, is actually this force, and then you multiply with sine of this angle. Okay, that's the first relationship. No worries. Okay, Eva, can you tell me in terms of this equation, how do I find fx? How much is fx?
Fx cos theta.
Check again. Fx cannot be fx cos theta.
I mean F cos theta.
Very good. Okay, f cos theta. So this is the second relationship that I want you to know. The horizontal component, okay, can be calculated by kita darab f dengan nilai cos theta of this angle. Okay, but there is a very important thing I must say. Okay, ini dua relationship ini hanya boleh digunakan. You can only use this relationship, okay, with this condition. Okay, the condition is the angle must be touching the fx component. Then you can use this. Do you see this angle? It is touching fx, it's not touching fy. Okay, so we can only use this equation fy equals to f sine theta and fx equals to f cos theta if the angle is touching the fx component. Okay, if it is not touching the fx component, then there's a different case. Okay, so for example, I don't know whether I have this space. Hold on. Apa ini slide ni? Okay, how to determine the direction? Okay, this is done lah. Okay, so now I'm going to use this as an example. Let's say my angle is here. Contohlah saya bagi begini. Okay, I give my angle over here. Okay, if you can see, actually, if you realize by now, we're not using tangent. Everything is sine, cos, sine, cos, sine, cos saja lah. Okay, so let's start from the same thing. Irdina, can you tell me what is sine theta? And Isabella, tell me what is cos theta. Fx over f, okay. What did I ask Irdina to do? I asked Irdina to do sine theta.
Fx over F, yeah.
Okay, thank you. Isabella? Is Isabella there?
Fy over F.
Okay, Fy over F. Okay, so because of that, kalau saya pindahkan ini F ke atas, saya akan dapat Fx sama dengan F sin theta. Manakala Fy is F cos theta. Because my angle is up here. Okay, di atas sini. So where the angle is actually very important. Okay, let me draw the original triangle we had just now. The original triangle was this. Okay, sorry. The original triangle is like this. So here is F, this is Fx, this is Fy, and the angle is here. Okay, if the angle is here, notice that my okay, so notice that my Fx is F cos theta and my Fy is F sin theta. This is just now punya example. So where the angle is actually very important. Okay, notice if the angle is up here then Fx we use sine. If the angle is down here, then the Fx we use cos. Okay, that's a very important relation and something that you must remember. Okay, when we're talking about resolution of forces, where you put your angle is very important. Okay, but if you want to make it easy to remember, then kamu ingat saja. Okay, you just remember this the component, okay, that touches the angle is cos. Kau tengok ah. When the angle touches Fy, then Fy we use cos. When the angle touches Fx, then Fx we use cos. Sebab remember our friend, cos is always with the adjacent. Yang di sebelahnya is always cos. So ask yourself lah, you know, when you do a question like this kan, ask yourself, is the angle touching the vertical or the angle touching the horizontal? Kalau angle itu menyentuh the vertical, like in this case, then the vertical is cos. If the angle is touching the horizontal, like in this case, okay, then the... Oh, berhabis saya menuliskan, tapi kau tidak nampak saya tuliskan. Sorry. Okay, kejap. I just realized I'm talking to myself, and you're not, and I wasn't really paying attention to what's being... Yeah, so the component that is touching the angle is cos. Okay, so Fy touch the angle, so Fy is cos. Okay, Fx touch the angle, so Fx is cos. Because we use ka. Okay, ka is adjacent, maka adjacent sebelahan. So whatever that is next to, or whatever that is adjacent to the angle, that is the one that you must use cos. Okay, so remember this rule lah. This rule very important. Mana-mana yang menyentuh the angle, itulah yang cos. Okay, yang the opposite of it is the one that is sine. Okay, okay. So this is where now we use number. Okay, let's hold on to this. Remember the rule. The rule is wherever the angle is touching, that is the one that must be cos. Okay, so let's think about this. Our force is 200 newtons. The secant force is 200 newtons. So the two components are to the right and to the up. Okay. Yes, please ignore my English. I'm going to use this word a lot. To the up, to the down is very weird, but we standardize this. Okay. Notice where the 50 degrees is touching. It is touching the horizontal component. So that means Fx will be cos or sine. What do you think? Oh, sorry, Jacinta. This class I must call people and then you answer. Fx will be cos or sine?
Cos.
Okay, very good. Can you tell me in terms of the number?
Cos 50 degree.
Di depannya is how much is the force?
200 Newton.
Very good. Okay, so it'll be 200 cos 50. Okay, we use the secant force, then we multiply it by the cos of that one. Okay, can you give me the value of this, Jacinta? Do you have your calculator with you? How much is 200 cos 50?
128.56
Okay, 128.56 unit.
Newton.
Very good. Okay, let's go on to let's try Fy. Now we find the horizontal the vertical component. Okay, Jericho.
200 cos 40 cos 40.
Oh, kau mau buat begitu? Jahat oh kau ni. Jangan jugalah macam tu. Okay. Christia, okay, fine. 200 cos 40 actually also is the same lah. 200 sin 50 lah. Orang mau kamu cakap 50, dia mau cakap 40. Kau tu. Okay, actually it is the same value, okay? Because, okay, think about this. If this is 50 degrees, then this is 40 degrees lah kan? Okay, since it's 90 degrees. And since the 40 degrees is touching the Y, so you can use cos 40. Also can. Dia bukan salah, it's not wrong. Okay, ini memang langkah genius inilah. Nampak kau baru pergi tandas kan, so it's good. Okay, tapi it is the same thing. Actually, it's true. If you, kalau kau tekan cos 40 and sin 50 on your, saya mau cakap telefon, sorry, on your calculator, you get the same value. Okay, so you can actually use that, also no problem. Okay, what is your final answer, Miss Genius? Tell you.
153.21
Okay. Unit?
Newton.
Newton. Okay. So, for those of you who are expecting this answer, 200 sine 50, kamu tidak salah lah, you're not wrong. But for those of you who want to understand, kenapa Chris Fia choose cos 40, you can ask Chris Fia lah. Okay, because okay lah, saya tidak jangkakan lah. Okay, that's actually a very smart move lah. Okay, so yeah, not bad, not bad. Okay, I'm quite impressed. Okay, let me continue. 153.2, very good. Okay, let's talk about this. Okay, so the component now is going this way, down right, down apa ini, left. So it's going downwards and leftwards. Okay, so let's talk about the fx and the fy. Lester and Louis, Lester fx please, and then Louis fy. The angle is 70 over here.
Fx equals 75 cos 70.
75 cos 70. Fx. When do we use cos?
This is sine.
Okay, sine 70, because the 70 is touching the y. Okay, how much is this value?
70.48.
70.48 unit.
Newton.
Actually, the unit is meters squared.
Okay.
Okay, yeah, I know. Okay. Let's just, I tell you, this slide is, okay, Louis, Fy please.
75 cos 70.
Okay, 75 cos 70. And the answer will be?
25.68. 25.65.
Lona. Okay, 25.65. Okay, newtons. Okay, let me remind you again. What do these two values mean? Okay, these two values mean that if I put a force over here at 70.48 and I put a force over here at 25.65, I will get a resultant force this way. Okay, yang warna merah ini menunjukkan the resultant force. Ini yang kamu belajar in the first subtopic. This subtopic is kita mau pecahkan the resultant force to two components. Okay, by using Fx and Fy. Okay, and we have to, there's no other way to do this lah. We have to do this mathematically lah. Memang cara matematik sahaja. Okay, but we use what we know about trigonometry, sine, cos, tangent. Okay, to help us to do this. Okay, now you have to watch all the animations again. Blah, blah, blah. Okay, let's talk about this now. Hold on now, my animation is very slow. Oh no, I'm lagging. Okay, can see this? Okay, so let's talk about this. This is the resultant force, people. Okay, the resultant force is, sorry, my circle is coming in very late. Kejap. Okay, this is the resultant force. Okay, it is going to the up and left. Okay. Actually, just now in the previous one, I made a mistake. It should be negative because we always assume that going to the left is negative. Actually, going downwards also is negative. Okay, but we can talk about that later. But this one, we may have to consider the negative. Okay, so this one, we're going up and left. Okay, hold on. My writing is taking a very long time to get to you. And I'm kind of not sure why. Okay. So let's consider this, the fx, okay, and the fy. Okay, actually the fx is this way to the left. Okay, sorry, hold on. My writing to the screen is taking a very long time. I already say fx and I already wrote down fx on my screen here. Tapi yang keluar di atas screen kamu is like taking forever. Okay, so the fx is actually this way to the left. Okay, but of course it is in a different direction lah. Okay, so take a look at this. This is the what do you call this? This is the resultant force. Okay, so the upwards is this way. Okay, that's the Fy. Okay, but in order for me to get the resultant force here, I have to have the green color one, which is to the left. Okay, which is the Fx. Sorry. Oh no, I know why I need this. Maybe because my Wi-Fi is a bit slow. Sorry. Okay, so this is how we will count the fx. Okay, let me show to you. We still use the same rule. Okay, we still use the same rule, except that we have to change the direction of the f towards the negative. Sebab dia pergi ke sebelah kiri. That's why you will get negative 5 sine 45. Why do we use sine? Melanie? Oh, opposite. Oh, okay, fine. Okay, sorry. So Melanie has answered lah. Dia sudah balik dari buat kopi. So because the angle 45 is opposite to fx, that's why we use sine. Okay, but don't forget we use negative because it's going to the left. Okay, the force is this way, tapi we have to use an opposite force because we want our resultant force to go another way. Okay, and Fy is 5 cos 45. Kenapa positif? Sebab dia ke arah atas. Okay, so you will get the same answer as well. Okay, so how about this? This is going to the right and to the down. Okay, so what component needs to change? The component that needs to be changed is the y component. Okay, so the y will be negative. Okay, the Fy will be a negative value, the Fx will be a positive value. Okay, Michelle, can you tell me the Fx, please?
6 cos 60.
Okay, 6 cos 60, which will be?
3
Okay, 3 what?
newtons.
Okay, very good. Mordecai, Fy?
Negative 5.196
Negative.
newtons.
Tell me the whole thing, please.
Negative 5.196.
Before this, sebelum ini, apa yang saya harus tulis?
6 sin 60. 6 sin 60.
Okay, negative 6 sin 60 lah. Okay, good. Thanks. So, okay, sorry, animation galore. Yeah, okay, since negative 6 sin 60. So that's why you get negative 5.19. You got 5.196 now. Okay, don't worry, it's fine. As long as you know, okay, that you may have to change the positive to negative. Okay, so let's consider this. So a car is being towed by a cable. So this is a very normal situation. Okay, a car being towed by the cable. Yeah, I kind of sense that our Wi-Fi is a little, I think it's my Wi-Fi. My Wi-Fi is a bit teruk here. So just try to bear with it. Okay, so a car is being towed by a cable, which has a force of 1,500 newtons. So this is the force. Okay, and it is at the angle of 60 degrees over here. Okay, so indicate and label the force F. So the force F is already given. The horizontal force is Fx and the vertical force is Fy. Okay, actually originally it's here lah. Okay, here is Fy. Okay, but since we want to make a triangle, okay, then we have to draw this one this way. Okay, so Oswald, the horizontal force please, and Shafiq Iqbal, the vertical force. Horizontal force is given by Fx and vertical force is given by Fy. Can you guys answer this? Is Oswald and Shafiq there?
1,500 cos 60.
Okay, very good. Shafiq, Fy please.
1500 sin 60.
Sin 60, and your answer will be
1299.03 Newton.
all right. Unit, very good.
Newton.
Okay, so yeah, so actually, thank you. So, so as you can see, actually, it's not that difficult, lah. Okay, you just have to know when to use cos and know when to use sine. Okay, so there we go. Okay, let's do another one. So let's think about this. The horizontal force obviously is this way, lah. Okay, and the vertical force is this way. Okay, the angle of this is 55 degrees. Okay, so let's have Rania and Tian. Same thing, Rania for the horizontal and Tian for the vertical.
Fy
Hmm.
equal 100 Newton sin 55
Okay,
equal to 81.92 Newton.
okay, thank you. Rania?
Fx equals to 100 cos 55 equals to 57.36 Newton.
Okay, 57.36 Newton. Thank you. Thank you. Kenapa ni Newton degrees? Thank you. So, see, I want to talk about this now. Why is it easier for a bag to be pulled, okay, than to be pushed? Okay, so, sorry, I have to go through all this animation again. So, if it is pulled, the vertical component, okay, y is upward, okay. But if it is pushed, since the weight of the bag is downwards, okay, then the resultant force is smaller. If you are pushing the bag, okay, let's say for example this man over here, he pushed the bag instead of pulling, right? He's adding more to the weight. There is more weight downwards. Okay, there is more weight downwards, kan? So it makes it more difficult to, you know, that the bag is already so berat. You push it some more, it makes it even more heavy, lah. Okay, so that's why you pull to reduce the vertical forces. Okay, the resultant on the vertical force. Okay, so that's a very important thing to note now. Okay, lady mopping the floor. I think this example is in your book, but never mind, we try again. Pushing force is this way, 32 newtons at the angle of 60 degrees. So let's consider this first. Okay, tell me where is the direction of the two forces. Oh, ya, saya punya line pun di sini stuck ni. This force bahkan, ini perempuan yang sedang menolak ini. Tell me what is the two directions yang terlibat. Sorry, can you see the screen that I'm presenting now? The two forces. Okay. Sorry, Okay, so horizontal component is Fx, vertical component is Fy. I'm going to get Wilson and Wilson, our two twins, to give us these two.
Fx negative 32 cos 60.
Okay, value?
Negative 16 Newton.
Okay, all right, very good. Wilson?
Fy equal to 32 sin 60.
32 sine 60.
Yeah.
Value?
27.71.
71 Newton. Okay, thanks. Okay, let's check. So negative 32 cos 60 is what Wilson said. Okay, so over here they give positive because they assume that downwards is positive, which is actually totally fine. Okay, especially if the movement is, you know, it's not really going left or right lah. Okay, and actually the downward component is also positive because Okay, because in this case, okay, in this case of this particular force over here, okay, the horizontal and the vertical components kan, you don't have an opposition force to it. Okay, bukan macam yang contoh tadi kan, remember our contoh just now, the resultant force is here, but the vertical force is over here. So it is kind of a different story. But if we are talking about usual situations where everything starts from the same point and they are virtually pointing in the same direction, we usually just use positive for everything. Okay, but it's okay juga tau. Actually, if you want to use negative, then actually it's not a problem because the negative just tells you the direction of the component. So it's totally fine. Okay, but in this case, I think in this example dia bagi, dia letak semua positif because dia cakap, oh, okay, ke bawah adalah positif, ke kiri adalah positif. Okay, suka hati, terpulang kepada orang yang menjawab lah. As long as you know which direction is positive and negative for you. So Wilson's answer is not wrong. Okay, Wilson's answer is not wrong because he is assuming that going to the left is negative. And it's not wrong, tidak salah. Okay, so it doesn't mean that just because the book says positive, one means die so must be positive. No lah. Okay, all right.